Hi guys, we're going to do Intro to Geometry Proofs. This is like part 2 from the previous lesson that we did, 2-5. Big ideas. In geometry, we'll use algebraic properties of equality that we reviewed yesterday. Well, not yesterday, but it's the last class, to help us solve problems and justify steps. We will also accept postulates and properties as true. So we're only going to work with true statements, okay? So here is a properties of congruence. It's very similar to properties of equality. You're going to have a table. We're going to talk about 3 properties that we use: reflexive, symmetric, and transitive. So segment, here we're going to write segment AB is congruent to segment AB. Angle, we're going to do angle A is congruent to angle A. So this is congruent. So segment AB is congruent to segment AB. That's same, repeat, repeat. That's reflexive. So reflexive is repeat. RE, repeat. Angle A is congruent to angle A. Same, repeat. Symmetric is if segment AB is congruent to segment CD, then CD is congruent to AB. So when you switch, that's symmetric. So S for switch. If angle A is congruent to angle B, the angle B is congruent to angle A. When you switch, same thing. That is symmetric for congruence. And then transitive is if segment A and B is congruent to segment C and D, and then C and D is equal to E and F, they're congruent, not equal, then A and EF, they're also congruent. So these are our segments. So if the first two is congruent, and then this is congruent, the first one and the last one is congruent. That's transitive. For angle, you have angle A is congruent to angle B, and then angle B is congruent to angle C. The angle A and C are congruent. So that's transitive. So it's the same thing as properties of equality when we did it in Algebra 1. Use congruence. Instead of saying properties of equality, we're going to say property of congruence. So next thing we're going to do is proof. Proof means a convincing argument that uses deductive reasoning. Logically shows why a conjecture is true. There are 3 types. 2-column proof. This is what we use. Please put a star there. Flow. Paragraph. So these are the 3 types of proofs. So 2-column proof is the most common type of proof. Lists each statement on the left. Justification, reasons on the right. Each statement must follow logically from the steps before it. So this is the most common one that we're going to use. So we're going to follow these bullets. So always use these notes until you get familiar with it. So here's a sample of 2-column proof layout. Given measurement angle 1 is equal to measurement angle 3. Prove measurement angle AEC is equal to measurement angle DEB. So here is the diagram. Angle 1, angle 3 is equal to each other. You can see the arc right here. And we're going to prove that angle AEC is equal to angle DEB. Okay? So here are the statements and reasons. So you're going to always have a statement on the left of the T-chart, and then you're going to have reasons on the right side. So first is given. You always start with the given, which is measurement angle 1 equal to measurement angle 3, and just write given. Because that's how you begin. And then we're going to prove is at the end, right here. We're going to prove that these 1, 2, and 2, 3 are equal to each other. So the first statement is usually a given statement. Each statement should follow logically from the previous statements. The last statement is what you want to prove. So let's write this down. You can pause the video and write it down. So I'm going to show you how to do these like here. But for now, I just want you to write these 3 things down so you know what to do. But you always start with given, and then at the end, you're going to end with proof. Because in between, we're going to write the reasons and statements why that is true. And they're always going to be true, though. We're always going to work with true statement. In a proof, in addition to algebraic properties, you may also use definition and postulates as your reasons. Angle addition postulate, segment addition postulate. Angles that form a linear pairs are supplementary. Definition of right angles, definition of supplementary angles, definition of angle bisector, etc. So I'm going to actually give you a paper that has these postulates in class. So you can write down 4 postulates. See the handout I gave you? That means you're going to use the handout, okay? So here is example 1, algebraic proof. So you have a diagram here. This is a linear pair, and that's a supplementary angles. You have 2x plus 30 here, and then you have x here. So statements, angle AOM and angle MOC are linear pair. So we know that that's a linear pair, and you're going to use the definition of linear pair. So here is the definition of linear pair. You're going to use the paper I'm going to give you for the reasons. So you have to write, the given is you're going to write right here, angles that form a linear pairs are supplementary. So I'm going to give you the statements. You're going to just write the reasons here, okay? So angle AOM and angle MOC are supplementary. That means angles that form a linear pair are supplementary. So you're going to write the definition of linear pair. Any linear pairs are supplementary. They're going to be 180. So right here, you're going to look at this right here and write the reasons. So definition of supplementary angles. So if you look at number 2, these two equal 180. That is a definition of supplementary angles. That's the reason for the statement. So you're writing the reason here and reason here using the paper I'm going to give you for postulates. And right here, in order to solve it, what they did is they substitute 2x plus 30 into this AOM, and then they substitute x into this. So they just use substitution property. So if you see a property they use to solve for x, which is what they're doing, you're going to write the property for reasons. So you can write the definition for reasons or property for reasons. And you can see that right here, they simplify. They didn't use distributed. Don't write that. Just write simplify. They just did 20. 2x plus 1 is 3x. That's CLT. Combined like terms, which is simplify. Plus 30 equals 180. And then we're going to subtract 30 on each side. That's subtraction property of equality. Suppo. And then the last, we did divide by 3 to get 50. That's division property of equality. As you can see, you can write the definition, postulate, and then you can also use properties, and you can also use simplify for reasons. That's how you do the proof. So I'm going to give these to you for now, and then you just have to write the reasons for each line. So let's look at example number 2. Given is angle 1 equals angle 3. Proof, angle AEC is equal to angle DEB. So the first one is, this is going to be written for you. You just have to write the reasons, okay? So right here, angle 1 and angle 3 is equal to each other. That's given statement. So write given as a reason, number 1. Number 2, you're going to write reflexive property of equality because angle 2 is equal to angle 2, the measurement. That's true. The middle is the same. And then the next one, you're going to add angle 2, add angle 2. So they're going to give this to you. So what you see is adding same thing left and right. That's addition property of equality. Next one, angle addition postulate. So what you're going to do is angle 1 plus angle 2 equals angle AEC. So right here, if you add these two, that's AEC. If I add 3 and 2, that's DEB. So that's called angle addition postulate. Because when you add these two angles, it forms one big angle. When you add these two angles, it forms the other big angle. And number 5, what you do is you do substitution, or you can write transitive if you want. So angle AEC equals angle DEB. Because if these two equal each other, that means these two equal each other. So you can write substitution because you substituted angle 1 and 2 instead of this. 3 and 2 instead of that, or you can say it's transitive property because if these two equal each other, these two equal each other, and these two equal each other, right? AC equal to DEB. So you can write the properties. Either way is correct, substitution or transitive. Example 3, given is AC equals BD. Prove AB equals CD. So right here is the diagram. That means AC equals BD, so you should make a mark. And then AB, two lines means equal, CD equals each other. So from here to here is equal to here. So I'm going to give you the statements. I want you to write the reasons. So why don't you pause the video and why don't you try 2, 3, 4, 5, 6 and see if you can check the answer and see if you get this. So why don't you pause the video and try this. Pause the video. Okay, let's check the answers. Number 2 is reflexive property because you have same thing left and right. Repeat, reflexive. The next one is segment addition postulate because when you add AB and BC, that's AC. That's the postulate, that paper I gave you. And then segment addition postulate for this one too. BD equals BC plus CD. The next one is substitution because you substitute it, and then last one is subtraction property of equality. So number 5 is substitution because instead of BD, you substitute it with AB and BC, right? So that's why it's substitution, and that equals this. Because they are same length. If you think about this, right here, you see the red line here, and then this red line, they're same length. That's why we can substitute that. Then the conclusion proof should be the last one here. So that means you subtract BC and BC here, and then AB equals CD. So in order to get this from here to here, 5 to 6, you subtract same thing left and right. That's why subtraction property of equality. Does that make sense? So we're going to do a lot of practice like this in class. So for this one, we're going to be given the reasons, and you're going to look at the given and the proof, and you're going to come up with the statement. So you know the first one is given, and the last one is proof. You need to look at the reasons and write the statements. So we're going backwards now. So first, you're going to write the given. Segment PQ is congruent to segment XY. Please write that. Next one, we're going to write definition of congruent segment using these two pictures. So congruent segment means PQ is equal to XY. Symmetric property of equality, that means you're going to switch. So just switch it. And then last one is prove. You prove that XY and PQ are congruent, the segment. Let's do one more. Given LK equals 5, JK equals 5, then segment JK congruent to segment JL, prove that segment LK means congruent to segment JL. So basically what they're saying is this side and this side is equal to each other. Prove to me that this side is also equal to each other. So this should be an equilateral all 5, 5, 5. So basically what we're going to write is given LK equals 5, JK equals 5. And then that means if this is 5, this is 5, then LK and JK equal each other. That's called transitive property. If this is 5, this is 5, they equal each other, that's transitive. And the next up, we're just going to write the definition of congruent segment. LK is congruent to JK. They're equal to each other. And then this part is given, so I'm going to write it here actually. And then the last one is if LK and JK congruent, JL is congruent, then LK and JL is congruent. That means everything is congruent. If this is 5, that's 5, that's going to be 5. Please pause the video and try this. There are missing spots. You're going to fill in the blank. And then I want you to check with the key. Please pause the video. Here are the answers. Please check. We will do more practice. Please pause the video and check. Thank you.